Hi everyone, my name is Matthew Greenwood and I'm joining this webinar from Meanjin or Brisbane. I'd like to begin today by acknowledging the Yagara and Turrbal people as traditional custodians of the land of which I am calling today and pay my respects to their elders past, present and emerging. As this is a webinar with people in a range of locations, I would also like to acknowledge the traditional custodians of the lands in which we all meet today and pay my respects to elders past and present. I would also like to extend that welcome and respect to the Aboriginal and Torres Strait Islander people present on the webinar today. As I said, my name is Matthew Greenwood, and I'm currently Acting Director of Minerals Geoscience at the Geological Survey of Queensland. As you may know, Helen Dageling has recently left the GSQ and moved on to an exciting position in the industry. I'm sure we'll continue to see her do great things, and I expect her to be presenting at our webinars and our GSQ events well into the future. I'm Acting Director while the recruitment process is being undertaken, but please note this doesn't affect the GSQ's commitment to our current work program or the webinars, and both these continue on without change. Today, our GSQ SMI webinar is titled Future Risks in Mining and Exploration, and I'd like to introduce our host from the SMI, Professor Nick Cook, Group Leader of the Total Deposit Knowledge Team at the W.H. Bryan Mining and Geology Research Centre. Thanks, Nick.
Thanks very much indeed, Matt, and Evan there from GSQ, and welcome to all our speakers and attendees online, of which I see there's 27 or so now. We are recording this session, so it will be available in the future if you want to come back to it. So I think without further ado, I'd like to start off. So we're forecast to have 6 speakers during the day, of which 3 come from one organisation who will be spread over 40 minutes. And then at the end of the day, we hope to finish up by 5:15 with an open discussion running for around 20 minutes or so. So I'd like to start by welcoming Ben Seligmann, who's also from the Sustainable Minerals Institute from the University of Queensland. And he's going to be discussing optimizing mine closure with causal network topology analysis. Ben, over to you. Thanks very much.
No worries. Thanks, Nick. And if I just get to the beginning. Okay, can everyone see that okay and hear me? Yep, sweet. Okay, well, look, nice to meet you all. And can I first say, I am not a geo. I am a chemical engineer by training, but I've worked in risk management and risk management research for a while now. So thank you for letting me in the door. I appreciate that. And if I make any faux pas, I apologize in advance. You may be wondering why I'm talking about mine closure when, of course, a lot of the flavor of what you guys all do is exploration. And that's why I've sort of altered the title of the talk a little bit just to call it Optimizing Mine Closure with something called Causal Network Topology Analysis, which I'll explain in a minute, with a view to opening up complex ore bodies. So I'm in the SMI, but I'm in a different research center from Nick. I'm in the Minerals Industry Safety and Health Center. And one of the key points that I thought to mention right off the bat is when we're trying to realize critical minerals for a green transition globally, there's one topic of discussion that hadn't gotten a lot of airplay compared to others, which is about the health and safety implications, the health and safety risks of these minerals. Now, I'm not an industrial hygienist or anything like that, but I thought I just wanted to start off with mentioning one of these critical minerals, vanadium, has a number of, as you can see on this diagram, has a number of potential health impacts. Now, this has been known about in the medical world for a while, but thinking about setting health and safety policy or managing risks on site of these new kind of projects, you can imagine new ore bodies being realized with trying to manage dust and all these sort of other health and safety impacts and risks. It's part of the picture of realizing projects. Now, this is well known. We have to manage health and safety risks, as well as financial risks, as well as environmental risks when we're developing new projects. But I wanted to flag it to say this is a key part of the conversation about the many types of risks that are on the table and that interrelate when exploring for these minerals. So the point is that various risks need to be considered together, and that's the key theme throughout my whole talk, in an integrated way in order for projects to be successful. So with that in mind, let's talk about closure. So mine closure is a complex issue, just as exploration and opening up of new deposits, especially complex deposits, are as well. Now we know, so closure is complex for a number of reasons, but not least of which is that there isn't a lot of successful examples of it. There's not a lot of data. But one reason in particular why closure is difficult is that different stakeholders speak different languages. Now, I mean, this is a metaphor, as is indicated on this slide. It does speak to this reality that each stakeholder, whether a mining company executive or a closure team member or the regulator or the local community, they have a different framework or a different set of key questions they're trying to explore, answer, which is related to a closure scenario. And those key problem framing questions, there's a related set of methods with them to achieve a particular set of goals. So for example, the mining company executives, the kinds of key questions they're asking of a closure scenario is, how do we divest ourselves of this site at lowest cost possible? And the goal there is about minimizing the cost of closure potentially. That's one approach. The methods that are employed to achieve that are accountancy methods, engineering design, delegation, things like that. Now there's a very different situation when we look down at the local community. The kinds of questions that local community members may ask of a closure scenario is, how can my unresolved grievances that are generated during the mine life, how can they be healed before the end of closure? We might want to have a thriving community as the goal of a closure process, but their methods of achieving that are very different from methods in the mining companies. They might be around negotiation and integrating between the government and the mining company. The key idea here is meaning. Each stakeholder frames the closure problem according to what is meaningful to them, and that makes that situation very complex. Because in general, stakeholders want different things, and therefore they see different risks. So how do you determine if risk overall in a closure scenario or in an exploration scenario with multiple stakeholders, multiple outputs, if adverse risk overall is low enough to be acceptable? Whose risk are we talking about? And which stakeholder are we talking about? But to actually achieve closure or to open up a successful ore body, we do need to come to some determination of residual risk and hopefully not ignoring key stakeholders that are there. That's why I mentioned the vanadium health and safety risks at the beginning. But there's a problem here. We need to have a clear and integrated approach for defining and determining residual risk, but risk management in general hasn't had a good history for being deployed in complex systems, such as systems with multidimensional context that besets mine closure and complex ore bodies. When systems become too complex for people to be able to anticipate all possible risks, the focus should be on preparing the system to respond to disturbances of any type. To do this well, a deep appreciation of the external context of the system or of the ore body or of the site is needed. And also the internal context, how the parts of the system, how they're all connected together. In fact, in ISO 31000, the 2018 version of the risk management standard speaks directly to these 2 points and says, I've quoted some parts here, when designing the framework for managing risk for the organization or for the project, the organization should examine and understand both the internal and external context. And here's a few interesting pointers that don't normally come out. In the standards advice, it particularly says, when examining the external context, you should consider the complexity of networks and dependencies. And when considering the internal context, there are interdependencies and interconnections that form part of the system that really need to be appreciated to be able to do a good job. This is about integrating across contexts. But the problem is, and I should just say, but engaging with the complexity of the networks, the complexity of contexts, and understanding the interconnected internal structures, it remains a challenge for most organizations. And this is because there are many types of context and that reflect the many types of stakeholders that a project has. How do we integrate them? But firstly, what are some of these different contexts? So this is a smattering, right? A snapshot of different kinds of ways of thinking about context for projects. First one is causal. Within the scope of analysis, how far sort of upstream and downstream causally do I need to be thinking? We need to look at the whole forest of risks related to a project from all types of places, not just my immediate context, my immediate focus. We don't want to miss the forest for the trees. The trees being, if I just manage individual risks really well, I might be missing a bigger picture that I can leverage. The next part is organizational context. So addressing things like organizational silos. This can affect how far I see in my system, and if I'm limiting myself to just the small patch of the world and managing the risks in my department, for example. If I compartmentalize too much. Another kind of context is what I've called informational, but that's really just saying that information about different kinds of risks sits in many types of data formats and data sources, whether that be quantitative models or audit reports or informal conversations or photos or risk registers. There's information about various types of risks to projects that are relevant to projects, but are split up, that are not connected together to fully appreciate the richness of the context you're really managing. And the last one, perhaps obviously, is stakeholders. And I've included a picture here about mine closure in particular as an example, but stakeholders have different contexts, have different goals, different paths to achieve their goals, different methods, different risks that they see. The big picture here that there are a lot of different parts of context to consider. This is a tricky situation. One way into this, to be able to start integrating across contexts, bringing the risks together to manage them all, is to have a clear set of definitions for what we mean of certain concepts to help do this. Now, this is the beginning of me talking about that method I mentioned before, causal network topology analysis. So causal network topology analysis, or CNETA, is its acronym, is a method that facilitates this translation and integration of contexts and risks, and allows a way of analyzing how the risks causally interconnect to enhance their overall treatment, or at least that's the idea. The place to start is to use a clear and sufficient definition for what an event actually is. And such a consistent definition can be helpful across different reference frames and different stakeholders. So for example, if we just skip down to definition of an event, here we go. This is a definition that we found to be helpful. Think of an event like this. An event is a change in a property value beyond some threshold embedded in space and time. And I've got some examples, so this is not too esoteric for you. So this kind of event here, increased pressure in pipe 1. So this is the sort of thing you might see in a HAZOP or other kind of process-related risk register. The property in this event is pressure. That's the focus, right? The term increase implies some change in the value of pressure beyond some accepted threshold, presumably defined elsewhere. This change will occur over some finite time period, even if it's very short. And pipe 1 refers to where this event is occurring. I've got another example here for you, which I won't go through now, but it's this sentence, which you might see in community consultation sessions and things like that. When the mine closes, everyone in town won't have any work. It's actually 2 events embedded in here. but using the same definition, we can identify them and put them into the same framework for managing these different kinds of risks. So just practically speaking, what am I actually talking about? How do you actually do this method, causal network topology analysis? The core idea is, in addition to doing regular risk assessment processes, looking at likelihood and consequence and that kind of thing, you can also look at the structure of how the events causally interconnect out of, for example, a risk register, which is what you can see here. If I can see here that I've just circled the different risk events, and the black lines represent causal links between them. And this is just a normal risk register, right? You take this kind of structure, but you represent it as a network, where each dot in the network diagram down there in the bottom right corner, the blue dots and the red dots, each dot is an event text that fits in a box from the risk register. And the causal structure that I've drawn on the risk register, that's the same structure that you'll see in the whole network. Those lines between the dots actually have a direction, but they're just very small arrowheads. Sorry about that. Once you've got, what's the point of this? You might ask, what's the point of representing your risk register as a causal network? So I said before that we use a very generic definition of an event, and that's to help us to look for events in many types of different data sources and in different contexts and integrate them together. So applying that definition in the middle, you can find things that look like events from quantitative models, from risk registers, from photos, from audit reports, from GIS mapping layers, from ecosystem trajectory models, from incident reports, etc. And that's how you then can bring them together, and we just put them in a spreadsheet at the moment to be able to connect the data points together. That's how you can bring them together and analyze them, and to see how they causally interconnect and thus affect each other. And so in Kineta, it's nice to be able to extract risk events from many different places, but the real magic is, the real artifact of study is the causal scenario, the causal network you get when you connect those events together, when you are able to distill their causal relationships and put them into the one format, because that allows you to analyze the topology. And the topology, I should just go back, is the structure of this network. You can see that this is an example network of a closure scenario. And the first thing to note is that it's fairly non-trivial. Each dot is a risk or an event, I should say, and the lines between them indicate how they're causally related. Again, the arrowheads are a bit small, but that's what those causal links are about. You can see that there's some evidence of, well, there are some risks that appear to be kind of more towards the center of the scenario, and some that are more on the edge. Some have lots of connections, lots of causal connections, and some have very few. What can we do with this? How does this help us manage all of these risks together? Because remember, the theme of what I'm trying to talk about is integrating risks across multiple contexts to be able to develop or manage the residual risk from many different stakeholders in different data formats and things like that. Well, these are three things you can learn from looking at a causal network or looking at analyzing risk in this kind of format. The first thing you can ask is, are there any risk events I'm missing? Am I missing key connections between islands of risk? Second question, and I'll go through examples of each of these in turn in the next few slides. Second question is, what might be the key risks or the critical risks that are driving this scenario, or that might be derailing this scenario? Another question I might ask is, what is the set of risks that I need to treat first, or that I might want to treat first in order to make the residual risk in general as low as reasonably practicable? Now, I'm not really talking about safety risks here with regards to LARP, but I just mean, is there some subset of all those risks that can help me prevent all of them? How do I find that? What's the best order to treat these risks in? Okay, so the first one, visualizing causal network. So just by visualizing the network, you're starting to learn about what does the overall risk landscape here look like? The first thing to note from this picture on the left is there's two big clumps of risks. There's actually three, that little one up on the top left as well. There's two major clumps of risks that are quite separate. First question I would ask is, well, if we're talking about a single site, a single closure scenario, why aren't they all connected together? Is there something missing? And you can see on the right in diagrammatic format, from the visualization of this risk landscape as a causal network, you can start asking questions about where might there be missing events, or where might there be missing links between events, which prompts a very different kind of discussion in amongst colleagues about how we're managing all of these risks together. Now, that's all very well and good, but you can actually quantitatively calculate a variety of what are called network topology metrics, or metrics that tell you something about the structure of these networks, to help you to do risk treatment planning and help you to prioritize events and various things like this, help you to manage risk or manage these risks, so understand how they function as a whole, right? So there's a number of examples of these metrics, and they can help to identify causally important risks. So there are two major classes. We've got metrics that apply to individual events, help you to prioritize them separately, and you've got metrics that relate to the entire network. So two metrics to talk about here from this diagram: the degree of a node, or the degree of an event, and the betweenness. So the degree of a node, or is the number of connections an event has, the number of causes and consequences an event has. It's not much of a stretch to understand that if I have a particular risk which has lots of causal connections, lots of causes or lots of consequences or both, compared to the other risks in that analysis, then that event might be kind of more important than other events. And I really should think about why is that getting so many connections? And if it is, does that mean there are lots of things causing it? Or does that mean there's lots of controls on this? Or what can I distill from this? You can see immediately I'm asking different kinds of questions about this risk landscape that you don't get to ask if you're just looking at a risk register. Another kind of metric, the blue dot there, is called the betweenness. So this is then basically a count of the number of causal pathways that go through a particular node. So I might use my degree metric to find the highly the events with lots of connections individually. But there might be an event which by itself doesn't have a lot of causes and consequences, but it's sitting on a bridge between two big clumps of risks, like in this picture. And maybe a well-tailored risk treatment strategy to find the events that have high betweenness could actually prevent large clumps of risks from occurring in the first place. And you can, and this is the same network diagram as I showed before, but just the events highlighted based on their degree score by the number of connections they have. And you can see here that there are a few risks, the red ones, the red or orange ones, which have quite a higher degree than others, right? That are more highly connected. And they're listed on the right-hand side in this mine closure example. So sustainability of native revegetation is not achieved, very high degree. That's a significant consequence, right? You would expect that to be highly connected, and that's exactly what you see. Another one, mine closes early. It's more on the upstream side, but again, it's having a big impact on a number of on how the scenario is progressing. So you can use the degree metric as an example of network metrics to help you to have a deeper and richer conversation around how to manage all these risks. Similarly, you can do the same for the other metrics. This is the color map for betweenness. The list of risks there is a little bit different. So the betweenness is highlighting different events that are causally important for different reasons than the degree metric. And you can use these together to really have quite a rich discussion around how do we manage all of these. The third advantage, this is the third thing we can learn, is how do we think through an optimal order for treating risks? Is that even possible? Yeah, well, there's a particular kind of analysis you can do with when you have a causal network called a robustness analysis. And this is about trying to understand how fragile is my risk landscape? How easy is it in general to prevent all these risks? Now, this is a model, so it's a bit of an idealized way of thinking about risk treatment planning, but it does give you a good indication of where to look. What robustness analysis is all about is what you do is it's trying to figure out how easy is it to break apart the network, which in risk management terms, how easy is it to prevent all of the risks from occurring? What I do is I choose a particular metric that I'm interested in that is causally significant, like the degree, for example. And I find the node with the event with the most connections, and I take it out of the network. And that's me representing I've prevented that event, okay? And then I also take away any other events that now no longer have connections. And then I recalculate the network to see how many nodes have been removed. And I do it again. I take the highest degree node out and I keep going. And that gives me a characteristic curve for the network. You can see on the bottom, the x-axis, the number of nodes I have to remove before the whole network disappears. So what this is saying is, if you look at the bottom there, the heel point, out of this risk scenario, this risk landscape for this closure scenario, I should say, there's 188 events in the risk register that are relevant. I only have to stop 29 of them before all of the other risks are prevented. Now, as I said, this is a model, but it does give you a clue of where I should try and focus my risk treatment based on the structure of the network. Now, in addition, we actually can work out what is the ideal order to prevent events in order to achieve this optimal risk treatment sort of endpoint. So I start in this example. If I prevent the mine closing early, then I try and address the native revegetation issue. Then I'm looking at geotechnical stability, and I can do this kind of analysis across from over all types of risks, from all types of contexts, from all types of stakeholders, once I've got it in a causal network. So, for example, the key risk to start off with might be, if I'm trying to manage a variety of types of risks, might be a reputational issue, and then it might be a safety issue, and then it might be a geotech issue. And we can look at this all together. Another way to apply robustness analysis is now this is not a closure example, this is a project feasibility example. I can compare different project options. If I have the risk registers for different potential ore bodies, do I do this one? Do I do this one? Do I do this? Do I do this one? If I do a robustness analysis on the three of them, I can actually say, well, this idea for a project is a lot more fragile than this one, which means it's easier to prevent all the risks over here in this project than it is for this one, based on the structure of their causal network and what I can learn from a robustness analysis. And I can see here that the linearity of the robustness curves, how straight it is, and another way of measuring that is the area under the curve. The closer it is to a straight line, the more complex the risk landscape is to manage. The more deviated from a straight line, the easier it is, because that means I have to take a few key risks out, and most of them are dealt with. But if the robustness line is very straight, then I just have to prevent them one at a time. They're actually very tightly interconnected. That's useful information to know if you're trying to think about project feasibility. And this kind of analysis can be done very early in the piece, as soon as you've got a detailed enough risk register or equivalent. So in conclusion, I think I'm about times a bit of time some questions, I think, at the end. How does Kineta help risk management in the closure space, in the complex ore body space? The key idea is it helps to integrate across multiple contexts, as I mentioned at the beginning, and multiple data sources to help you understand the risk landscape. It helps you to find missing risks by changing your discussion in your team around missing risks and causal links, and to visualize the causal network. It helps you to find key risks that could significantly derail your scenario. That's using the topology metrics like the degree or the betweenness score and examining the structure of your network. And it can help you to suggest an optimal order, or an idealized, I should say, order for treating risks to reduce risks in general through robustness analysis. And there's other things you can learn from robustness analysis as well. It's important to know, though, that of course, this is not a panacea. Kineta is not a panacea, but it opens new doors and different ways of thinking about managing risks for closure or for complex ore body projects in a different way, in a more holistic way that hopefully enables more successful outcomes. Thanks very much. Do you have any questions?
Thank you very much indeed, Ben. So we have a Q&A channel here that is open. So I'll wait a couple of seconds and see whether anybody writes in the Q&A channel.
Really good talk, Ben. I've got one quick question before anyone else jumps in.
Yeah.
The model you explained, that the causal network topology analysis,
Yeah.
how does that deal with changing levels of acceptance of risk? Should a risk be determined as low, and then over time it becomes more heightened, I suppose? You know, how does that affect the model, and how regularly should the model be reviewed and reconsidered?
So the input data for Kineta is, think of it as your risk register, right? So the decision about whether a risk is acceptable or not will affect whether that risk ends up in the risk register or not. And so it changes the input data.
Yeah.
And so Kineta really is an analysis piece after you've got that. So it doesn't directly connect to changing acceptability of risks, but the changing acceptability of risks will change your input data.
Yeah, okay.
Thank you for the question.
That's right.
Thank you very much indeed. I think you've either confounded them or they're very satisfied, Ben.
Well, hopefully both, you know, in some sense. Look, as we go across the afternoon, if you do have questions about this talk in particular, put them in the Q&A. I'm sure we can find them and bring them out at an appropriate time. Or you can email your questions in. I imagine they can do this, Evan, to yourself or to me directly.
Yep,
and we can talk offline. So that's quite okay.
Yeah, perfect.
Fantastic. Thank you very much indeed. And we've unshared. And can I see Carrie? Yes. So welcome to Deloitte Consulting. A cast from Carrie, Jason and James, who will run for the next 40 minutes. And it's the title is Deloitte Tracking the Trends, Mining 2023. So welcome all, and the floor is yours. Cheers.
Thank you very much, Nick. So hello all, it's a pleasure to speak with you today. My name is Carrie Grimes and I'm a partner in our Deloitte's Climate and Engineering practice, where I focus on major program delivery, operations transformations, and performance improvement in heavy asset industries. I've spent the majority of my career working primarily in mining, but I've also done work in major infrastructure programs, oil and gas, and utilities. I'm joined today by my colleagues, Jason Go and James Owen. Jason comes with a similar background to myself, experienced in delivery of major capital programs, and most recently has been focused in the critical battery minerals space. James has a background in mechanical engineering by trade, with more broad experience in open cut and underground mining, oil and gas, and broader industry experience. He specializes primarily in the operational readiness space, as well as supply chain management. Today, we'll be covering 3 of the trends from our most recent release of Deloitte's Tracking the Trends report, which is focused on mining industry. So our Tracking the Trends report is released on an annual basis and covers 10 of the most prominent trends that our mining experts are seeing and experiencing globally. This year, the trends are focused around the indispensable role that mining and metals play in our society and economy on a daily basis. And most importantly, as we look to accelerate the energy transition, the role that mining and metals has in that space. Jason, if you go to the next slide, please. So the topics we will deep dive into today are conscious circularity, driving down embodied carbon and metals, and rethinking the external talent pathways. There are, as I mentioned, 10 trends, but these are the ones that we deep dive into based on the content that other speakers are covering, as well as where we see some of the most interesting risks as well as opportunities in the mining space. So talking through the first one in terms of conscious circularity. So as you all know, mining has long been driven by liability and resource scarcity. So there is an understanding of that unconscious circularity. However, there's a lot of work still to be done in the conscious circularity space and those mindsets around value and material reuse further down the value chain. So what do we mean by unconscious circularity versus that conscious circularity? So as mentioned, the mining and metals industry is well progressed in looking at waste recycling, water reuse, and the creation of products from tailings is becoming more prominent in the conversations that I've been having with clients to date. So the notion of circularity is also being adopted in that energy space with mine electrification, energy storage, and companies that have been regenerating landscapes for some time now. However, these initiatives are mainly driven by liability and regulation and resource scarcity rather than looking at that value creation. So when it comes to conscious circularity and shifting mindsets around value and materials reuse further down the value chain, there's still a lot of work to be done. Since the linear economy drives the need for mining, there's also that tendency to perceive the circular economy as a threat to the mining industry as it is right now. Systematic change is often considered risky, too costly, and also difficult. So that typically results in action being put in that too hard basket. Now, you might be asking yourself what can be done to initiate and accelerate the circular economy in mining and metals specifically. So one of the things to de-risk this area is organizations need to get strategic. As part of org-wide strategy setting, mining organizations need to start considering how they define and measure that value today. If the current system doesn't accurately reflect non-financial forms of value, they should explore how it could be rethought to support the creation of circular economic center-based business cases. By questioning what is valuable today, what was valuable 10 years ago, and what will be valuable in another 10 years' time, businesses will be better positioned to build the circular principles into their core strategies. So it takes some forethought and action in planting this into the strategy conversations that are already being played out and thinking a bit more about the future. Next, organizations need to map their value ecosystem. So from what we've been seeing, it is likely that most mining companies will already be mapping their sphere of influence as part of their Scope 3 emission reduction efforts, largely due to regulatory and shareholder requirements. However, they could leverage this exercise to consider that value flow throughput into the known ecosystem of suppliers, customers, stakeholders, and environments. From there, they can identify the roles that their company plays in each of these scenarios, as well as the threats and risks and the opportunities to value retention, and understand the gaps that could present an opportunity for new product, service, or alliance to really drive that value creation. Mining organizations also need to invest in the appropriate people and partners. They need to consider whether the organization currently has the knowledge and capabilities needed to apply circular principles and close any value leaks. They also need to be strategic about the roles and identify where investment is needed to build resources in-house or where it is potentially better to outsource to a business whose values are aligned. Furthermore, mining organizations need to look at how they scale current successes. Circular principles can be applied at every level within a mining and metals business, from the process levels all the way up to the enterprise. So from what we've seen at the moment, companies are good at applying the circularity at the process level, For example, mining companies using closed loop water circuits to reduce loss through mineral processing. Where leading practices, they can leverage leading practices that currently exist, replicate and scale them across the business. Furthermore, the sharing these examples and learnings both internally and externally will also accelerate the industry's collective impact. I think we see good examples of operations identifying opportunities for these improvements. As you get into the major mining companies, though, being the large organizations that they are, they often lose that ability to quickly share or apply and scale the concepts that they're already used. So finding those mechanisms to share those ideas throughout the organizations across different areas of the business can go a long way to drive that circular economy. Lastly, mining organizations need to act fast to safeguard their market share. To help ensure mining and metal companies maintain competitive market share, circular economics should become a core strategic imperative. Many traditional mining companies of all sizes are pivoting to embrace the circularity, and there will be new entrants in the coming years, no doubt. There's also the threat of the rising costs as ore grades decline. Early circular economy adopters should not only benefit from preferential access to responsible sourcing markets and investors, but these companies also have the opportunity to influence those downstream, accelerating the growth of the wider circular economy. So, as most of you on the call would know, mining minerals and metals from the start of many different supply chains, from steel used in wind turbines to potash and phosphates used in fertilizers, to metals used in electric vehicles and their batteries. And while collectively the industry still has a bit to go, they already have a lot of the fundamental resources and skill sets required to establish and really embed those circular economy principles. So we feel the industry is well placed to move quickly with the right focus. Now I'll pass to Jason to talk through the next trend. Thanks, Jason.
Thanks, Carrie. The next trend is driving down embodied carbons in metals and really supporting the decarbonization of economies. So what do we mean by that? If we think about the creation of low carbon, future fit yielding materials, vehicles, energy technologies, and more, this is all reliant on minerals and metals from which their key components are produced. It should come as no surprise that although the mining and metals industry does contribute to global carbon emissions, the sector has a foundational role as a provider of raw materials, which means that its handprint or potential to lower carbon emission across the global economy outweighs its footprint. We think about what we're seeing now in the industry, efforts are well advanced to lower Scope 1 and Scope 2 greenhouse gas emissions. If we take a look at research from the University of Columbia, it has shown that 90% of total emissions from mining and metals globally actually originate from manufacturing of iron and steels. Scope 3 or avoided emissions produced by these activities, go up and down the value chain. And this really includes smelting and refining. And when you look at the research, it can constitute up to 98% of an individual company's total greenhouse gas emissions. So if you think about how does this compare to Scope 3 decarbonization efforts, these have only really begun in earnest. Part of this lag can be attributed to the time it takes for companies to map out their complex supply chains and work with alliances to align their thinking. It also takes time to identify where existing processes and technologies can be adapted to low emissions and where the development of new ones are required. What we're seeing in the market right now is increasing supply chain pressures from manufacturers of end products, such as batteries, cars, phones, and packaging. And, what we're also seeing is for mining and metals companies to provide verifiable carbon neutral commodities. A proactive approach to lowering Scope 3 emissions will allow early movers to differentiate themselves in their products, potentially capturing a greater share of the market. So, how do we actually think about this and what can be done to create a clean tech portfolio that supports Scope 3 reduction? I guess the first would be go digital to map the business ecosystem. And what comes to my mind is a quote from Albert Kubitsky: "The map is not the territory," which is a point of view of pragmatism, beginning with the understanding of the value chain better by digitally mapping where Scope 3 emissions come from, and by gaining a deeper understanding of the different layers of industries involved in the company's value chain, their associated emissions, organizations can generate better insights about how their business activities are ultimately associated with Scope 1 emissions. This transparency and visibility makes it easier to evaluate where companies can influence the development of abatement options, potentially a future lens of offtake agreements. The second option is identification of abatement options. I guess the saying here is make time to listen to your suppliers and customers. There may be collaboration, investment, or enablement opportunities that are available to the organization that they have not yet considered with both direct and indirect players. Once the opportunities have been identified, prioritize, set boundaries, set data sharing protocols, and support the initiative. A recent example that really comes to mind is the critical minerals in the EV industries. OEMs are aiming to manage policy-driven incentives from the European Union and North America on sourcing and emission. That's the Inflation Reduction Act and the Fit for 55. And so what we're actually seeing is the development of frameworks that assist in their decision-making over the selection of upstream raw material supply. The easy go-to is cobalt from the DRC, from a social responsibility perspective, to cobalt that's produced in Australia. Next, you need to be clear on costs, transparently assess and address the commercial implications of the value chain decarbonization. This is really about understanding where capital will be required, the value in the end product, and how to redistribute that value along the value chain. Form a view of the least cost decarbonization pathway for that full value chain. After that, we've got seek out collective actions for greater impact. And what we mean by that is Scope 3 emissions can only be effectively addressed by the industry working across the value chain. The creation of buying consortiums that value this reduction and are willing to invest in these options, may provide that premium offtake market for investors. We're seeing that beginning to move really in the funds industry. A good example that really comes to mind is the ELYSIS project. This involves Apple, Rio Tinto, Alcoa, and the government of Canada or Quebec. They're working together to develop a greenhouse gas emission-free smelting technology, an example of a powerful collective action, and also some of the future-facing technology where we think India is going to invest in this type of technology. We previously discussed Think Circular, so I'm not going to cover that. And the final one, as always, is make sure you understand the time frame. Solutions must be developed, optimized, and scaled to achieve, the net zero target of 2050. And finding those alliances who want to collaborate, to develop these solutions and then synchronize. And this is the key word here: synchronize their changes across the value chain to improve timing and scalability. Once a single value chain has been assessed, develop that roadmap, scale across your products, and then identify the order of priority based on timing or really market demand. Thanks for your time. I'll now hand over to my colleague, James.
Thanks, Jason. Good afternoon, everybody. Appreciate the opportunity to be able to share. Rethinking external talent pathways. It's a very interesting subject for many reasons, and I'd like to introduce it by, I guess, considering, like many other global industries, mining and metals continues to see unprecedented changes that are impacting its workforce and the ways we work. Among the prevailing challenges, companies are scrambling to navigate a fast evolving labour market, and amid the global shift towards purposeful employment, this is compounded by efforts to rebrand the industry in line with responsible sourcing and energy transition. Our consultation network from Deloitte Canada explains that we've been hearing a lot of commonalities in the mining and metals industry and the challenges our people face across continents and countries. We see leadership teams working to balance labour shortages with booming demands. There are also requirements to attract and retain the appropriate talents and skills, source diversity of talents, bring forth diversity, equity and inclusion in the workplace, and shape and embed sustainability into our organisational DNA. By effectively charting a course through these concerns and better reflecting the value of people within our corporate strategies, organisations can secure a future-ready pipeline of talent. So what does this mean? To illustrate the magnitude of today's shortages across mining and metals market. First, as mentioned, there's a worldwide rush for minerals as countries work and pivot away from fossil fuels towards decarbonisation. Simultaneously, the mining workforce is ageing, and the looming retirement of experienced employees, combined with low recruitment numbers from younger generations, means there's a danger of critical knowledge and skills being lost. Today, the average mine worker's age are at least 46, and nearly 50% of skilled engineers are reaching retirement age in the next decade. As the nature of jobs evolve, so do the skills needed to perform them. According to the World Economic Forum, industries are facing a reskilling emergency globally as more than 1 billion jobs are likely to be reshaped by technology over the next decade. So to tackle this, leaders are exploring ways to balance and strategize between sourcing for new talent and upskilling and reskilling the existing workforce. In doing this, it's important to focus on the soft skills of today while also preparing for the technical skills of tomorrow. Companies will need to improve workforce planning and update their operating models to respond to new roles, new teams, and new priorities, including preparation for that energy transition and our sustainability goals. We've seen a lot through the COVID-19 pandemic, accelerating the shift away from siloed ways of working in mining and metals towards a more integrated, intelligent operations approach. This is increasing, and industries are adopting digital technologies, artificial intelligence, analytics. In particular, the use of remote operations centre or nerve centres is creating new roles, such as nerve centre orchestrators and data scientists, integrated master schedulers, team performance scientists. Many of these roles have similar counterparts in other industries. For example, emergency response coordinators who could find exciting opportunities in the future of mining. So what can be done to rethink the organisation's talent pathways? We need to tell the appropriate stories, changing perceptions of the mining industry by using its role as a catalyst for sustainable social, environmental, and economic growth will likely be central to attracting new talent and creating an environment that retains people in the workforce. Companies should actively seek out opportunities to engage with younger generations through multiple channels. And these connections should be made early and often. For example, community outreach initiatives to job fairs at universities, mine tours for children, etc. There are many ways to create this interest in the sector. For instance, a video game company, Minecraft, has partnered with the Mineral Council of Australia, University of Queensland, and Mining Education Australia to bring gaming into the classroom and make mining a part of the school's curriculum. The industry's purpose must be central to communications and efforts. Build foundations that underpins environmental, social, and governance, ESG on the ground. Focus on developing quality, two-way relationships with local communities. Form a collaborative approach to social development, which allows mining organisations to develop and respect through on their ethical promises, while building a positive reputation among local talent, creates better understanding of the existing skills and the exciting capabilities base that the mining and metals industry has, and the future needs of our local workforce can be developed. We need to source talent from home and abroad. Companies must find a balance between building skills within local communities, outsourcing or borrowing skills and jobs from internationally, and bringing exited talent back into the sector through incentives. Particularly with that aging workforce, And these approaches are necessary to successfully execute on future work. Companies should leverage automation, digitisation and possibilities of virtual and remote work. Get creative. Moreover, this shift towards the energy transition intensifies. New jobs with new skills and capabilities will be needed. It's an exciting future. To respond to this, mining and metals companies should find more creative ways to source talent. Recruitment tactics must be supported by an employee value proposition that resonates with the younger generations. This means that both purpose and social ethical values are created. It's in closing, I'd like to refer to earlier points regarding circular economy and the decarbonisation opportunity. Much of what I've discussed relating to solving workforce challenges, I can see are assimilated in the concept of circular economy. Each role within the organisation can be reconfigured to encourage experience back into the workforce. We can focus on the strong skills of today and prepare for the skills of tomorrow that have been learnt by our children, the talent of the future. And there is a lot of opportunities to create exciting new roles and bring people into the workforce who are excited about these opportunities. As we heard from Jason, developments such as value chain decarbonisation provide opportunities for exciting new roles, opportunities to speak to younger generations who are keen to work in a purposeful sector and invite new ways of thinking and working. I'll hand it over back to Evan.
Well, thanks, James. Let us do a quick intro back, Jason, on the next slide quickly, just to close out, sorry, the final one. So just as I mentioned previously, our Tracking the Trends report does have 10 themes. We talked about 3 of the ones that are driving the most risk at the moment, or ones that we are coming across more frequently, I should say, and the work that we do. And really highlighting, the role of mining and metals is truly indispensable if we're going to achieve the energy transition in terms of, what mining and metals provides and enables into the energy transition. But thinking through, what are those skill sets? How do you drive that circular economy? And how do you make sure that you decrease the carbons that are inherently in metals throughout the process, or inherently linked and are only part of that equation in terms of what we need to think about de-risking, and really reframing it in terms of, the opportunities that lie ahead for us. I think James mentioned in terms of, how important storytelling is in terms of attracting and retaining the right talent, but it's also the storytelling is important to making people understand the importance of mining and metals in our economy, in our society, and in the energy transition more broadly. And so making sure that we are sharing these stories and these teachings to shift that mindset, and also, being the future-focused lens of mining becomes inherently important in the roles that people play in the mining industry. So not just those of the mining organizations, but also organizations that lie adjacent to mining organizations as well. And just doubling down on that importance goes a long way to bringing more positivity, but also that understanding of the criticality into broader society. So with that, again, Evan, thank you for the opportunity to present today. I'll hand back to you.
That's great. Thanks very much, Carrie, Jason, and James. I can't see any questions in the Q&A or the chat just yet, but I'll give it a moment or two. But I've got a comment for you first and foremost for James. I've been on my son's case about spending too much time on Minecraft, but perhaps he's laying the groundwork for a new career. So that's really exciting to hear, that lateral thinking, that taking a program as a game and looking at real world applications. So if you have anything further to share on that particular topic, I'm happy to relay it to my son. But yeah, more of a comment. It's great to see companies looking at those avenues, because that's the way of the future, looking at some of that education, through enjoyment and gaming and the like.
Evan, I just came from, I guess, let's call it a global discussion on Spot the Dog. Boston Dynamics, where they've got that artificial dog, how we think about remote operating sensors and how we control some of those machines to do, emissions testing, heat sensor testing, in quite sometimes inhospitable places. Think about underground mining on a particular mine site. That transferable skill from gaming into a remote operating center, that's actually quite a real world application that's being tested at the moment.
Yeah, fantastic.
And a question for James, in relation to the education market. So we have, I suppose, the situation that we have a group of young kids at the moment who are at school, with a group of teachers who are perhaps not trained about how important mining is. Then we have a group of people at universities who, by and large, you wouldn't say were in favour of the industry. And certainly when you look at government funding with a bums on seat model, you see Australian universities closing geological departments. So I've had thoughts about how we turn this around, but one of the arguments I would make is that at least educating teachers gives us a chance for the next generation. But I'd be interested to hear what your thoughts are on that sort of Gen XYZ sort of situation that we have at the moment.
Thanks, Nick. Good question. I think back to about 12 years ago, I was invited to go to a primary school at Youngula up in Mackay, and it was a very small school with a mixed age group from year 5 through to 7, and it was basically engineer in a classroom. And we had 2 sessions. One was building a geodesic dome out of newspaper and sticky tape, and the other one was building a boat and racing the boat as a competition, made out of straws and sticky tape. The interest from those kids, and you could really see those that loved building things and discovering things, was incredible. And from the teaching staff also, broadening their mind around what we do. I think it's important to reframe. Perhaps I like calling it the resources sector, but I can think of reframing another example of waste management. I like to reframe that into resource recovery. Okay, so I think getting out there and getting more exposure with the young people and definitely the teachers, and really presenting that without a purpose of trying to change people's attitude towards mining, but to educate.
Okay, thank you. I mean,
Nick, if I could add one comment to that. I think right now, if you think about critical minerals and the role it's going to play in, let's say, the EV market or the energy transition, especially if you think about copper as well, and and if you want to expand it a little bit further, defense around some of those resources required for the military. It's a useful narrative to then think through, okay, how do we actually take something that's interesting, bring it to new world application, bring it to households, and then drive that conversation. And so for me, it is a bit about the narrative piece. I don't think we're going to win the thermal and metallurgical coal discussion. I think that's going to be very challenging, but very important that we respect that sector. And then we just think about, iron ore. It's still going to be the world's largest requirement, right? So I feel you, Nick. I think it's a lot of community, grassroots, social media, other ways of reaching out those educational opportunities versus than just in the traditional classroom.
Yeah, and we need to make it exciting again. I mean, bizarrely, my year 12 class from from Dunedin was actually only 7 of us, and 3 of us became geologists, and we're still geologists. So I'd love to see that ratio propagate into the modern world, but I don't think we're ever going to get there again.
I think you can look at some of the examples from other industries or heavy asset industries. If you take Cross River Rail, for example, they have an experience center set up in terms of way for community engagement. So there is that way to build excitement around it, and setting up those types of experience centers that engage individuals at all levels can serve to educate. And again, I agree with you. It is an uphill battle to an extent, but there is a lot of exciting stuff that, if reframed and if education is provided appropriately, I think there is some wins to be had there just with that reframing. So I don't think geologists I think there's still hope out there.
Yeah. And I mean, the whole VR underground world and how it all works is pretty spectacular. There are a couple of Northern European universities, Nordic ones, doing that sort of stuff, and really introducing that into the classroom in the sort of gaming world would be something really quite intriguing. So yeah, I agree. There's lots of really cool things we can do. And we need to try and move there fairly quickly. Otherwise, we'll find that there are fewer geological and mining engineering facilities left in Australia, or educational ones anyway.
Completely agree.
Okay, are we, Evan?
Yeah, sorry, no, Nick, Evan here. There's no further questions or comments in the Q&A or the chat, so I'll hand back over to you.
Okay, well, thank you very much, and thank you everybody for keeping to time. Really appreciate that. So now we're going to go from Deloitte to PwC, and I welcome Lachlan Smith, who's a director there at PwC. PwC's extensive perspectives on future trends and risks in mining. All yours.
Thank you very much, and apologies in advance, Nick and team and Evan, if people can hear a bit of elevator music in the background. I hope that won't be too painful. I'm just squatting here at the Hilton after an event, but let me know if that is a little bit challenging for people, and I'll try and find another space. Let me share my screen at the risk of death by PowerPoint, and I will try to make this as engaging as possible, given that I've only got a few slides here, and it's such a comprehensive presentation that we just received from the Deloitte team. That was really interesting, guys. So my background is a little bit different to the earlier speakers. I have an economics and economic policy background, and that's where I spend most of my time in PwC. Given the prevalence and prominence of mining and resources more broadly in Queensland, that's where a lot of my work gravitates towards. But as Ben said at the open, I am certainly not a geo. So hopefully these perspectives will come at a more macro level, but still be useful context in terms of how we face into the new financial year and beyond. They also take a fairly industry-focused perspective, given that a lot of work that PwC does is with our private clients in the resources space. I might start with the overview of what we predicted about 12 months ago in terms of the macroeconomic landscape that the resources sector in Australia and globally actually is facing into. So this comes from our Aussie Mine report that's produced each year and largely focused on small to medium tier miners, the top 50 in that category. We saw three broad trends impacting the industry over the 12 months from when that report was issued, and I think largely they have come to fruition. The first is the global economic landscape in terms of persistently high inflation combined with increasingly low unemployment and low growth in much of the world. Some of those factors coming together for the first time in many decades to the extent that we have subsequently seen. in many respects, that has been a boon for the mining industry in terms of prices, as you all know. But in terms of the macroeconomic landscape that the resources sector more broadly situates in, it is a challenge for many economies. The second trend relates to a tightening of the labour market, and I guess in response to that, industries like resources have three avenues to address it, and building on James's points around talent pathways, I think they are in equal parts looking at your adjacent industries and opportunities to reskill and upskill. So we've certainly done some work recently looking at what the skills gap analysis looks like in priority resources related industries in Queensland, from hydrogen to renewable energy through to advanced manufacturing and to core mining. And we would see quite a prospect of upskill and reskill, but requiring quite a deliberate effort to identify occupations and to look at the size of that challenge in terms of taking traditional resources jobs and looking at other occupations. Electrolyzer-based occupations, for instance, will be a big part of the future in parts of Queensland like central Queensland. So adjacent industries and reskilling and upskilling we would see as one avenue out of a tight labour market. The other one is obviously increasing interstate and overseas migration. Queensland has been fortunate enough to experience quite a population boom post-COVID. You know, we have 6 times more interstate migration than our nearest counterpart in Western Australia. So that magnetic pull to Queensland is certainly happening. Again, the alignment challenge to make sure that they are the right people with the right skills, or could be the right skills in the future once they're here. But then also overseas migration is really ramping up again as well. And there is obviously quite a federal discussion about how do we reform and reshape our overseas migration targets and our priority skills lists to be more aligned to where priority industries go in the future. And then the third avenue out of a tight labour market that PwC sees is a commitment to growing your own. And in Queensland, we've certainly seen that focus in the workforce strategy that the Department of Employment, Small Business and Training has put out recently. The focus on identifying career pathways at to middle school and above, aligned to industry trends and priority industries like critical minerals, is only going to increase in emphasis in the future. So we do see a grow your own pathway out as well, but we appreciate that is something that needs to start now with people who are in the early stages of their high school journey. It's not something that you can necessarily switch on and expect that tomorrow you have that domestically produced workforce of the future. So we anticipate that tight labour markets will persist for some time. And then the other point is geopolitical uncertainty and what that means in terms of manifestations of supply chain uncertainty as well. So, you know, when this report was produced, the war in Ukraine was in its early stages, but the persistent disruption to our supply chains remains a concern. And when you look at Queensland's aspiration and the government's aspiration to develop a value chain in the resources sector that persists well beyond extractive parts of the cycle and into midstream processing, advanced manufacturing, you know, a domestic renewable energy industry, for example, you know, there is very much a sovereign supply chain aspect to that responds directly to the geopolitical uncertainty that we are experiencing. I think the Pacific is also a component of that in terms of the persistent narrative around hard power and soft power in the Pacific, and where we have traditionally sourced some of our raw material imports actually for some of our resources industry, and whether that will continue going forward. So that's a bit of a primer about where we saw the macro trends that buffer into the resources sector heading into 2023. I might, rather than me doing a monologue, I might ask if there's any questions along the way.
I'm keeping an eye on the chat and the Q&A, so none at this stage, Lachlan, but should they pop up, I'll let you know at regular intervals if you like.
No worries. Okay. In the meantime, I hope everyone's enjoying the elevator music. Let me move to the next slide if I can. So in terms of the three key trends that we then see in the industry for 2023 and beyond, we see it in three parts. The first is the supply chain sovereignty issue that I touched on in the previous slide. Security of material supply is increasingly paramount and is being seen at an alliance level around the world, not limited just to domestic sourcing, but trying to diversify the reliance on markets that now look geopolitically less stable than they perhaps once did, and China is obviously a big part of that. The interesting response from government to me is this increasing willingness to stand in the market from countries that you may not have otherwise expected to take that view. So if I look at the United States and part of the European Union, for example, significant global developments like the Inflation Reduction Act and the Critical Materials Act have been indications that national governments are prepared to stand in the market to connect raw outputs, so extraction of materials, with value-added outputs such as an advanced manufacturing industry that they're trying to stand up as part of a pathway to decarbonisation. So, for example, in the US, the Inflation Reduction Act has indicated that a certain percentage of domestic or friendly shoring supply of raw inputs is required in order to receive manufacturing tax credits on value-added outputs. And I think that's a great indication of countries where previously the hands-off approach was very much, government should get out of the way and facilitate things in the quickest possible way, but without market manipulation, is starting to shift a little bit as that the supply chain sovereignty challenge becomes more acute. And I think from a industry perspective, that dynamic sees portfolio optimization opportunities for miners to similarly stand in the market and transact across the value chain, actually both across and up the value chain, to add upstream materials and suppliers to their asset portfolios, reducing volume offtake and price volatility risk, and just generally be a more active participant in the supply chain. So we would see those trends on a supply chain level persisting for some time. Obviously, price and surety of access are key barometers of that, and should supply chain stability increase quite quickly in the years ahead, maybe that equation changes. but it is interesting to see the changing role of government in trying to turn the tables a little bit on how that supply chain reliance piece looks in order to maximise their resilience domestically. I think in terms of the US, Canada has certainly been the beneficiary of that in terms of having a considerable amount of raw materials and a regulatory environment that's quite attractive in terms of being able to pump prime the American advanced manufacturing industry associated with renewables. And so there is a live question about what is the role of similarly friendly jurisdictions like Queensland and Australia more generally in connecting to some of those developed world developments. The second trend is quite connected to the point that Carrie was making in terms of conscious circularity. I thought that was a really good point. We certainly see ESG excellence and closing that loop as no longer something that should exist or does exist as a buzzword or even as a point of differentiation for companies. In the resources sector, it is now the minimum operating standard, and Australia is actually well placed to compete on the world stage with ESG. There has been quite a bit of media recently about other resource intensive jurisdictions like Chile, Ghana, the DRC, places like that where the ESG record, both environmental, from a labour perspective, it is just fairly appalling actually. And so, in terms of where Australia takes its ESG excellence and the provenance of its processes, could very well stand us in good stead. But our view would be industry needs to do more, because society is demanding that we do more. So society is demanding an increasingly higher bar. And, I think we are long past the days that industry gets away with, sponsoring the local AFL team in, the Surat Basin or the Galilee or somewhere like that. And that constituting something like social license. Industry is being held to account on genuine offsets, tax transparency, things like that in terms of the expectations on what ESG excellence is and why it's important. I touched on provenance a little bit earlier, but in terms of companies having direct oversight of how their resources are extracted, how the systems and processes that exist around their extraction, then what happens to that mineral or commodity through the value chain and out to market will be increasingly important. We see the traceability and the provenance of that relationship, not just the raw rock itself, but everything that has been done around it as being a long-term point of competitive advantage and sustainability for the resources sector. The third trend that we see is one in relation to the decarbonisation agenda and the growing role of critical minerals as a critical input to that process. These are minerals that were once deemed to be secondary prospectivity, that were pretty tricky to segment from the core reason that you were mining, and often dumped in tailings dams as a result. Over the last several years, the perspective on that has gone full circle, not just in relation to decarbonisation and renewables, but in relation to the demand for the types of technology outputs that require critical minerals inputs in terms of electric vehicles, smartphones, things like that. So we see for some time still a supply deficit relative to the demand for critical minerals globally. We see that as being something that will continue to have a lag factor about it in terms of the major investments that are required in exploration, production, processing, refining to catch up with and to close that gap. That gap is nearly closed on technologies like solar cells, at least in their first and second generation form. Although future developments in solar may mean that gap widens again, depending on how the technology shakes out. But certainly in wind, certainly in battery, we would see a significant deficit persisting for quite some time. An interesting thing for GSQ and for the Department of Resources more broadly in terms of your relationship with industry is that mission critical path to development of a global critical minerals industry will require more mining, not less. So the stats from some of our reports indicate that the production of a solar farm requires 3 times more mineral resources than a similarly sized coal plant, or constructing a wind farm needs 13 times the equivalent resources to a gas-fired plant. So extractives for decarbonisation is a story that we see persisting for, and quite a generational story for the industry for quite some time. Again, I know that's fairly high level, but in terms of macro trends, does anyone have any questions about that?
Nothing at this stage, Lachlan, but my ears definitely pricked up when you mentioned the role of the department and GSQ, in I guess addressing the critical shortage and in fact increased requirement to do more and get on with it. Does any of the reporting that you've looked at talk to, I guess, at a high level, how and when, or can you dive a little bit deeper without getting into too much of the nitty-gritty as to what government's role has been identified as?
Yeah, absolutely. So, yeah, I think it's a really interesting question. What are the levers available to government? What is the role of industry? How does that dynamic work into the future? And again, I think locally you've seen evidence that the Queensland government's prepared to stand in the market a little bit. So you look at the announcement in recent months about a common user processing facility in Townsville. You look at the potential for government to be part of the solution in terms of the regulatory environment, zoning and things like that. Not necessarily in critical minerals, but certainly with the renewable energy zones in as part of the energy and jobs plan. These are examples of where government increasingly knows that they've got levers available to them, and they're willing to pull them from an industry development perspective, not just from a regulatory and compliance perspective. So I should at that point give a little bit of a shout out to 2 people I think who are on the call, Dr. Heather Sparks and I think Stephen Budd, who we're working with on some of this at present right now, actually, in terms of getting under the hood of what is the role of government, what is the role of the authorising environment, how do we meet that dual imperative of making the industry development task as easy and as fast as it can be, given that supply-demand equation, but then also recognise that this ESG excellence obligation will persist, and we should expect, and I think Queensland society would expect, that whatever we do in this space in terms of developing a new extractives industry is as sustainable as it possibly can be.
Yeah, I agree completely.
In terms of the broader trends and risks, I mean, a lot of them have been covered already today, but there are a myriad of them. We see them in four broad categories. Sustainability, I have talked about a fair bit already, but you know, as you can see on screen, I've drilled down into some of the component parts, some that we potentially haven't touched on to date. Things like cultural sustainability, the nature of workplaces in the industry, and making mining an attractive place to work that is diverse and inclusive, and doesn't continue to represent in the general community's minds some of those old stereotypes about the nature of the work, who does it, where they do it, what it looks like to be out on a mine site, things like that. The other sustainability piece is a bit of the technology resilience space, and being able to as industry participants protect yourself from some of those risks around cybersecurity and access to data, both access to data and then being able to, where appropriate, avail yourself of the benefits of technology in terms of more open source approaches to getting the right data, protecting the most secure data, but getting access to other data that might be beneficial to achieving a common understanding of what you're trying to achieve in the sustainability space. There are a heap of trends and risks relative to the revenue and growth prospects of the industry, and this is a list that we often step our private clients through. So I won't labour it here, other than to say that I see that supply chain and value add integration being increasingly important. So your relationships with original equipment manufacturers, for example, it cannot and will not be the case going forward that extraction exists in isolation from what you do with it once it hits the truck or hits the rail. So that there is a financing, a deals, and an M&A relationship to all of that. And there are also new market players. A lot of the critical minerals players are quite exploratory, as this group knows all too well, and don't necessarily have the same sort of capability levels as some of the incumbents from other commodity types. Productivity and automation is obviously an enduring challenge and opportunity, not just in terms of AI, robotics, some of those global trends, but in general, your productivity and optimization using technology equation. That is something that has existed as a I think that stream in grey there would have been on the list for many resources companies for the best part of the last 20 years. And I think that space just continues to evolve. Again, the role of data there will only become more important. And then the final one is the operating margin. So while prices have been not just pretty good, pretty incredible in the last year or two, volatility remains a bit of a risk, particularly at certain commodity levels. So we would see that smoothing out even at a slightly lower price point as being something that industry would see as beneficial. If you think about the main challenge for industry remaining investment certainty and pipeline for product, then having prices bounce around all over the place is not accretive to that. So there's some of the more enduring overall risks to the landscape as we think about how the industry continues to evolve. A couple of months ago, we produced our half-yearly Aussie Mine update, and that continued to show a really strong result for the industry in terms of shareholder value growth, price growth, the market capitalization of our industry. It continues to grow at such a rapid clip. So market capitalization of $162 billion being 33% higher than just 6 months earlier. Operating in that landscape is a blessing and a curse in terms of when you can expect to get to a more long-term planning for sustainable growth. When you have a dynamic like that.
Lachlan, it's Evan here. I've got a question that's come through. I hope it's okay.
Sure.
From Karen Fogarty. I understand a lot of these aspects are being addressed by tier 1 companies. Do you see the smaller companies able to meet these objectives?
Yeah, great question, Karen. And I would say that a lot of what I had on that. So if I go back to that previous slide, don't know what's happened there. Maybe I won't go back to that previous slide. Here we go. A lot of this list is actually what we talk to small to medium miners about. So the big end of town, the tier 1s, usually have this stuff wrapped up pretty well. They've got whole teams that wrap themselves around each of these streams. But a lot of this is designed to say to our small to medium miners, if you're not thinking about this now, somebody else is. And yes, we appreciate the investment landscape where oftentimes you are proving up a resource, getting the endowment profiled, and then looking at either selling up the chain to a bigger fish or listing. We completely get that market dynamic. But in the event that you want to take it all the way and you want to try and grow your company and not sell out, these are the things you need to be thinking about.
Great, thank you.
I think this may be the last slide. In terms of a deeper dive on opportunities and risks associated with ESG and the value chain, this is just an extract from our Aussie Mine report, where we've gone a bit deeper about how you might think about ESG and your value chain. Across the various stakeholders and sections of your development. So a couple of points to draw out here. One that we haven't spent a lot, or I haven't spent a lot of time today talking about, is First Nations engagement, and not just having that relationship based on approvals and land access and things like that, but actually having a genuine and multifaceted relationship with First Nations communities, and that as much as anything goes to attracting and retaining talent. It certainly can't be a case that, and there's been very high profile instances where commitments are made to progress to a point where you've got operational activities and then the relationship falls by the wayside or is not maintained to the depth that society expects going forward. And then the other one that I would pull out here is having the final consumer in mind. So when I talked about provenance earlier and being able to trace the relationship from you sort of your rock to your PowerPoint, for example. Consumers expect that, and are increasingly desiring that they understand that net equation from a sustainability perspective. So, electric vehicles are a classic case in point, where some of the presentation to market previously had been a comparison with, the fossil fuel outputs of running a car. And I think increasingly they are about, where does all of the steps in a value chain get to in terms of the net environmental outcomes from inputs, outputs, and then how a consumer uses a product like an electric vehicle battery that has component parts sourced from Queensland. So I think the consumer is increasingly telling us that they are not terribly interested in carbon-intensive products in the value chain, even if the piece of kit that they get out of it, or the renewable energy that they use to power their home, is at that point in the chain, fairly sustainable. That they actually care about the entire ESG chain. And then perhaps a final one. Again, I haven't spent much time on it today, but biodiversity and rehabilitation requirements. So we would see this space only intensifying in focus, and obviously the Queensland government has evolved its approach to rehabilitation and financial provisioning in recent years. But I think we are well past the days that that proponents can expect that they are able to leave stranded assets or not be responsible in the handover when they do sell, their mines, for example, responsible for picking up some of that rehabilitation effort. So that's a quite extensive space in its own right, but we would see again the ESG expectation from an environmental, social, and a government perspective, actually intensifying on the rehabilitation piece over time as well. I might stop there, Evan, and just see if there's any further questions from the team.
Yeah, sure. Nothing else has cropped up yet. But no, thank you very much, Lachlan, for your talk, and no worries on the audio side. Could hear you loud and clear. So yeah, you found a good spot to give the presentation.
Okay, terrific.
On the Q&A, nothing just yet. I might just defer to Nick just to keep the schedule on track. We're doing a great job so far, but yeah, you're off the hook for now, and I'll hand pass over to Nick.
Fantastic. Thank you very much. I'm just trying to open a presentation here for Sarah.
So Nick, just to make it clear, I can share the presentation myself. It was just if anybody wanted the slides, that's what I've loaded onto the website for everybody.
Okay, yeah. Great. Okay, brilliant. Thank you very much indeed. Okay. We're off and racing again, and we remain ahead of time. So I'd like to welcome Sarah from, is it Sartala? Is it a long A?
Sartala, yeah.
Yes, Risk and ESG Consultancy. And you're going to be talking on emerging risks regarding mineral exploration and production with a focus on critical minerals. All yours.
Fantastic. Thank you very much.
Just before you get going, Sarah, just shout out to Sarah for joining us this morning. I'm not sure what time it is in Belgium, but yeah, really appreciative that you made the effort to join us in a long time zone away. So thank you for that.
No problem at all. Having said that, I can share my slides. There is something very strange that's going on here at the moment. My apologies. I tell you what, would you be able just to maybe bring one of the old presenters back? I'm going to have to log on and come back in again in order to get this fixed. It's not going to work. So just give me 2 seconds. My apologies, Evan.
That's right. You there, Nick?
I think Nick is actually on the phone at the moment.
Ah, okay.
Yep.
All right, well, we might have a short intermission. This shouldn't take too long. I guess I might hand back to any of the other presenters who have been on so far. So Ben, Carrie, or Lachlan, if there's anything further you wanted to flesh out from the talks you've heard, or any other comments to make at this point, I guess the floor is open. Katerina as well, if you've got something a comment to make, please feel free.
I suppose a comment was just that, and a number of the presenters probably already over this, but I just a thought I had that in the discussion around opening up new systems and things like that for development, considering both upside and downside risk in an integrated way, but not just when you're talking about money. That's quite natural to talk about that when you're talking about managing different financial risks, absolutely. But when we're talking about the spread of ESG and safety and other things like that, there are like wellness versus safety, right? The two sides of the same coin. How do we plan, set up approaches to this kind of space, which is managing upside and downside risk together for all kind of risk categories in the one breath? I don't have an answer by the way, but I think it's a good idea.
And apologies for dropping out there. I pushed the wrong button and then had lost the screen somewhere or other. One comment I would make that I was interested in following up with you, Lachlan, and other people is that we tend to show this wonderful diagram of all the metals used, but that doesn't truly reflect the amount of material mined. And we show this massive number for iron ore, which of course I would regard as 73% effective because in terms of an iron ore mine, because it's very high grade. But then you look at the amount of copper mined and people forget that you've got to divide it by 0.02 to get essentially the amount of material moved. And so we're continually sort of, I suppose, fooling ourselves and the market that the amount we dig up is actually related to the metal. It's actually related to the grade. And we probably need to be a bit more careful about that in the future, I suppose. And it's you see it in all of these beautiful diagrams and you say, oh, we only use this much. But in actual fact, because it's 100 ppm, it's a lot of dirt.
It's a great comment, Nick. And one thing I would say is that is only going to be exacerbated when we step into the challenge of the critical minerals industry more fulsomely, because when you look at the amount of dirt that needs to be moved for that process and the intensity of the extractive process there, it is as far from a keyhole surgery as you can get. So in terms of moving great swathes of dirt to find what was previously the discarded gear and now is the good gear, in terms of what you do with that and how you transport that, whether you have, for example, a hub and spoke model in terms of where those great volumes are processed, and then your aspiration should be to move some of the midstream componentry to the coast. That whole equation to try and lessen the impact of the dirt that you are shifting around, I think will be a key challenge going forward.
Yes, absolutely. Absolutely. Okay, welcome back, Sarah, from Brussels. And let's see if you can share your screen and we'll be on the way. Cheers.
Yeah, let's try again. Can you all see a screen? Does that work now? Yay, we have the technology. Brilliant. So hello, everybody. My name is Dr. Sarah Gordon. As you can probably tell from my accent, I'm from the UK, but I'm over in Brussels today because the Department for Environment, together with the Department for Employment and a number of others, are about to launch a guideline document all about how to manage your risks within mining, and that's everything that's onshore extractives. Really focusing on risks pertaining to health and safety and environment. So I'm here today, hopefully, to get this over the dotted line and available to everybody. So I'm crossing my fingers and praying, but I suspect it might take another 6 months, but that's all good. That's all good. So I'm originally a geologist. So it was lovely to hear people talking about grades and tonnages, etc. just now, fantastic. But I went from the world of exploration geology into on-site geology and then into sustainability. So I have a strong background in that world of sustainability and then went into the world of risk and assurance. And the reason that I did that from a personal perspective was that I was living and working in Brazil, and I was working for one of the world's larger mining companies. We were in the process of divesting a couple of assets, and being one of the more technical people and sustainability people that was there, was helping them to write the management presentation, etc., that always gets used within that kind of divestment or mergers and acquisitions type activity. And what I found was that whilst the company really did care about sustainability, actually when it came to making those big decisions from a company perspective, perhaps they weren't necessarily included in that decision making to the same level as, say, the financials were. And so in order to try and help all of that come together, I thought, well, hang on a second, how do other industries do it? How do we usually bring together different potential threats and opportunities that as a network then help you to say, well, what are we actually looking at here? Knowing that the world is constantly changing. And of course, that's what takes us into this wonderful world of risk management, as was beautifully articulated by Ben earlier on. So building on that, back in 2014, founded Satala, which is a risk management and sustainability consultancy. About 50% of our work is with mining, and our constellation of fabulous experts based all over the world work with mining companies, investors, communities, etc., to help make sure that actually we do understand what these risks might be they potential threats or opportunities. So I'm going to give a shout out to Deborah Watson, who I know is on the line at the moment. She's our managing director for Satala Australia, but we've got teams elsewhere as well. So obviously not as big or as well known as Deloitte or PwC, but just saying we've got a little bit of expertise as well, and often work with other consultancies too, which is great. So on the subject of emerging risks regarding mineral exploration and mining, I'm going to focus a little bit on the critical minerals, but also as well, of course, give a shout out to all of the other people that do fantastic work in this space. So I'm calling these recognized risks in mining, in inverted commas, and I'm going to come clean with all of you. A couple of hours ago, when I logged in for this call, I just had the EY list of risks here. So thank you, Deloitte and PwC. I have quickly added your ones into the mix as well, just to say, okay, everybody does a really great job at saying, okay, well, what are we seeing when we're working with different companies, with different players across the sector? And what you can see here is there's really good alignment between what we're seeing, no matter which angle we look at the sector from. And what is important when we're taking a look at what these risks might be is actually being able to say, okay, well, actually, risk means something different to different people. So I think some of the presentations that we've had today have been absolutely fantastic, but have really been focusing on what do these risks look like from a mining company perspective, be it a large mining company or a small mining company. Now that's really important for us to be able to understand, but actually when we look at the world of mining and the provision of raw materials and what those threats and opportunities might be, they look slightly different for a government, and they look slightly different for a community, and they look slightly different for a customer or a consumer. So therefore, when we're bringing together this diversity of perspectives, it's really important for us to acknowledge the fact that actually what might be something that's positive for one stakeholder actually might be negative for somebody else. And actually, when we then begin to dive into it properly, all of these things that we call risks can be both threats and opportunities all at the same time. So this is something here, when we start getting really academic about this, there are many different international standards that we can go to say, okay, well, what do we actually mean by this word risk? And when we look at these things from an enterprise perspective, which is basically an integrated perspective, which is what most organizations are moving towards with regards to how they actually do risk management in their organizations, we find that the majority of international standards say that a risk is something that's uncertain, that if it happens, it's going to matter to us. And then they go to town on saying that those risks can be threats or opportunities. Now, here we have a problem because, of course, most people, when they hear the word risk, think that it's something nasty that might happen. From an academic perspective, actually, a risk can be an opportunity or a threat, and is really a little bit of both. Okay, so when I say the word risk, I'm meaning both threat and opportunity, but it doesn't really matter what language people use at all. So with this, the actual value of managing risk is where we begin to say, okay, well, where can we take action or put something in place that tries to reduce the total amount of threat that we might face? But whilst doing that, and actually there might be areas where we take action just to create opportunities for ourselves as well. And that is where we get the full value of managing risk. And that is what is meant if you are aligning with those international standards. That's what you're looking for. The other thing to mention with regards to this is when we're talking about the process of risk management, many people just focus in on the risk assessment. And that's lovely. That's wonderful. But to be honest, there's no point in doing it. And I say that in a very emotive manner because I know that risk assessment is really important. But there's no point in doing a risk assessment unless you're actually prepared to then do something with what you find from it. So the whole point of a risk assessment is about working out, okay, are we comfortable with where those risks are at the moment? Are there places in which we can take action to actually take a bit more control of our destiny or what's happening next? And so therefore, let's go and do it. Because risk management is about change. It's about changing something to do with your risks. And it's also about acknowledging where there might be changes going on outside of your control, or things where you might only just be able to kind of nudge it or influence it from quite a long way away. That's what we're actually doing here, because at the end of the day, we're saying, okay, given the context in which we're attempting to operate, and bearing in mind our context is changing the whole time. So given the context in which we're operating and those potential threats and opportunities that we face and our ability to actually manage them, can we achieve our objectives? That's really what we're talking about when we're talking about risk management. Can we actually achieve what we've set out to do? Now, if the answer is yes, we can achieve our objectives, then great, we've got everything in balance and we can carry on. If the answer is no, we can't achieve those objectives, we've only got two options. And one of those options is not go away and do more risk analysis. That might be important, but it doesn't actually give you the answer of what you're looking for. It might contribute to it, but it's not actually making that big decision that you need. So those two options that we've got here are either pump more time, money, and effort into doing something about those risks. And by this, it's not a case of we should do this. It is go do it and see if it works. And so that is option number one, pump more time, money, and effort into actually changing something. Now, if we can't do that because we don't have the cash, or we don't want to do it, or maybe it's not our place to do it, or something like that, then our only other option we've actually got is to relook at those objectives. Now, this thing here is really interesting, especially when we come to the energy transition and the raw materials that are needed for the energy transition, because the big problem we've got is that we can't actually really change those objectives. I mean, yeah, we can play with those targets in terms of emission reduction, etc. But actually, climate change is a massive ticking clock. And if the scientists are even a smidgen right, we have a big problem. And so therefore, actually, all of the energy and effort needs to be in here on managing those risks. And we don't have time for saying we should go and do this or that. Actually, it's a case of getting on and doing it. But in the world of raw materials, we know, and unfortunately, we have a track record of getting it really wrong and causing massive disasters, be they environmental, be they social, be it people losing lots of money, whatever the case might be. So this is something here where actually in the world of exploration and development and production and everything, the time is really exciting right now. And this has only really happened globally, I think, over the last 18 months or so. We suddenly see this massive step change that is being driven by the world waking up with regards to if we're actually going to meet any of our climate change targets, then we need to be able to produce all these raw materials in a responsible way. How on earth do we truly do this? And for the first time, perhaps ever, we've got a variety of stakeholders coming to the table that we've never really seen talk about minerals and mining before in the way that they're currently doing, which is really, really exciting. So with all of this, before I get going into some of the areas that are perhaps super exciting, is to give a nod to Ben. And Ben, this slide was in the presentation before you gave your talk today. So yeah, I totally agree with you that the world of risks, everything is interconnected. Everybody uses slightly different language, etc. You can classify things in different ways. It doesn't really matter. But basically, one person's risk is somebody else's cause, is somebody else's consequence. And it is all chaos and a mesh altogether. Where risk management gets really difficult is where we try to classify things because the world doesn't fit into boxes. It's a messy network and you've got stresses and tensions that fit in amongst all of this, which is great. The other thing as well is around the time scale of those risks, and a number of the presenters have already mentioned the time scales of risks. We are really good at visualizing and preparing for those short, sharp risks. And that's in part because we've had a huge amount of focus on health and safety risk management in the world of mining, which is fine, it's great. But the problem that we've got, the challenge that we've got, is actually many of these risks that we're beginning to face now are actually these ones that build over time or are the slow burners. So I think I spend my life speaking to people who don't think that climate change is real. That's fine. Everybody has their, is welcome to have their own perspective. But of course, the regulations are now here. So actually, we have to step up and do something. And this is something here where we don't have time to hang around and wait to see if that risk will happen. So we don't have time to wait to see if the risk events are real. Actually, when we're talking about risk management and the timing, it is about when do we put these controls in place? When do we put those actions in place? It's not about when the risk might happen or how likely it is to happen at some point in time in the future. It's about, do we need to do something about it and what kind of action do we need to take? And so this therefore gets us all to think, oh, hang on a second. Yes, we need to act now. We don't have 5, 10, 15 years to wait and get more data. We need to just get on with it and accept that we are going to get some things wrong here and there. We are going to waste a bit of money, etc. So finally, on all of this, when we're talking about integrated risk management, again, from a discipline perspective, this is something where it's all about integrating the different worlds of risk management together. So be it the health and safety risk management, it's not replacing anything in health and safety, it's making use of all of the great information that comes from fantastic tools and techniques that we have within that field. Similarly, on the financial risk management side, environmental risk management, etc., everybody uses different language. It is total chaos out there, but we don't have time to get hung up on terminology or whose approach or whose tool is best. At the end of the day, we need to instigate some change pretty quickly. Otherwise, we've got some fairly large problems that we're staring at. So, as you can probably tell, I'm a bit of an optimist, so I tend to talk about risks from the opportunity sense rather than just everything being doom and gloom. And that's perhaps because, of course, as I mentioned, I started out life as an exploration geologist, so we're perpetual optimists. We always think there's something in the ground. We're usually lying, to be brutally honest. Yes, I did just call exploration geologists liars. Maybe it's not liars, maybe we're just deluded. But again, it's our perspective, so we need to be able to take that into account. I'm glad I've got everybody laughing. This is fantastic. So what are some of the emerging risks that perhaps we see coming down the pipeline at the moment that build or certainly complement what we've heard from our previous speakers? So I'm going to try and come at this from a slightly different angle. And this angle is also influenced by the fact that about, 18 months or so ago, I was really very privileged to represent the Geological Society at COP26. So that was the big climate conference obviously held in Glasgow, which was hilarious because I think usually it rains the whole time in Glasgow and it didn't rain at all during COP26. It was glorious. We should have more climate conferences in Glasgow. It makes the weather much better for us. But whilst I was there, it was amazing being in that environment, which was quite different inside the conference compared to what the media portrayed it to be. Watching the, I guess, the relationships between different negotiators, for example, the media, different experts, and different observers as well, who were in this big conference. And during the conference, it was fascinating to watch and really exciting, but also incredibly frustrating. I think I heard the word mining mentioned twice, and both times it was, it's evil, it's wicked, it's all just about coal. And I thought, okay, that's an interesting perspective. Yes, coal mining is part of what we have here, and we need to be able to recognize that in its place in terms of our energy mix. But where on earth do we think we're going to get all the stuff that we need for our wind turbines, our photovoltaics, etc.? So I was asking people in this conference, well, these are lovely targets, but how on earth are we going to hit them? Because where are we going to get all these materials from? And I was told that mining was not welcome at a climate conference. Now, that was November 2021. And of course, it was the UK government that was holding the pen on COP26 at that point, or at COP at that point in time. And what was going on behind the scenes, though, was that gradual recognition that, hang on a second, within the UK, back in the 1980s, we had some strikes that had something to do with mining. And basically, ever since the 1980s, if you were a politician and you stood up in Parliament and you mentioned the word mining, you basically lost your job. It was not a good thing to be standing up and talking about. And almost as a result, because we have so little mining of like domestic mining in the UK, actually from a government perspective, a lot of the knowledge in terms of how do we actually do things like the permitting for a quarry or a mining asset, how do we actually do that? That's something that's being pushed further and further and further over to one side. So much so now that if you are an operating asset or you're an exploration asset in England, Wales or Scotland, it's a bit different in Northern Ireland. Everything was just done through the planning department. So there was no distinct department, or it wasn't very clear at all, and it still isn't, in terms of where do you actually go to in order to be able to get permission to be able to do something. So it's not as streamlined and say compared to some other countries. The other thing as well that we have in the UK is some fairly archaic laws. So for example, if you find anything that's precious, such as gold or silver or whatever in the ground, then it belongs to the Crown. And that's okay, that's fine. It's just a strange niggle that we have to be able to deal with if we're exploring for something like that. And that's fine if you are in England, Wales or Scotland. But if you're in Northern Ireland, there are some people who like the Crown and there are some people who don't like the Crown. And we've just been through the anniversary of the Good Friday Agreement. So of course, that's the peace agreement with regards to all the troubles in Northern Ireland. This is something here where mining is at the heart of this. And recently I was over in Northern Ireland doing some work with some local communities there, really trying to understand, well, what does this actually mean for us as communities? You know, what does this mean in terms of the rights to these materials? So anyway, that was just an example of, in terms of our ability to get our hands on these raw materials, it wasn't even being considered 18 months ago. Now, since then, what we've seen, of course, is huge change. And as many of the speakers have already alluded to earlier on today, over the last 9 months or so, the Americans have put on the table the Inflation Reduction Act. And by the way, again, from a UK perspective, we spell that out. We don't say the letters because that makes us all duck for cover because it means something else, especially in London. So the Inflation Reduction Act, of course, has basically put a huge amount of money on the table and said, hey, everybody come to the US if you've got something to do with green energy. Okay, so a huge number of innovators, etc., have moved what they're doing across to the US. To try and counteract some of that, of course, the Europeans have put in place the Critical Minerals Act, which is still being ironed out at the moment. This week, there are at least 6 conferences going on across Europe with people trying to iron out different bits of it. So it's going to take a little while to settle. The strategy deployed by the Americans and the Europeans is quite different, and it's very interesting seeing how different different countries, different nations, for example, are going at this. From a UK perspective, of course, we're just little guys in this particular pond, but this is where we picked up the phone to our friends such as yourselves in Australia and said, hey, remember the Commonwealth? Yeah, we did that thing called Brexit. You're now our best friends. So this is where we're seeing some really interesting trade agreements, for example, being put on the table across the world. And it's all about this stuff that I've got on the screen at the moment, because everybody is thinking, hang on, we need security of supply. And for our industries, for example, that we have, so in the UK, yeah, we've got very little domestic mining, but we make lots of cars. So where on earth are we going to get the materials from to actually make these vehicles? So you're seeing big shifts in terms of the need for these materials downstream, etc., and the availability of them. So there's massive opportunity that's sitting out there at the moment. But with this opportunity, there's that opportunity to explore for new materials. Now, of course, these materials aren't new. It's not like we've suddenly invented new elements in the periodic table. They've been there forever. But it's the demand for these materials that's changing. And with regards to this, we've been developing technology very quickly, and some of that technology is still changing. So with regards to, say, photovoltaics, there are different types of technology that require different elements, different metals to go into it. For example, some photovoltaics require tellurium, others don't. So this is something here where if and where a government says, you know what, our industrial strategy, or we have a strategy where we're going to go with that technology, you can see the alignment, the immediate alignment of what is actually needed in order to be able to deliver on that technology falls in behind it. If a government doesn't say, we're going to go with that technology, we're just going to have solar in general, or to be honest, we're just going to have renewables, that's fine. But what it means is that it's very difficult for the materials sector, and with that I'm including mining, to then align behind, well, what do you actually need? And this, without giving anything confidential away, these are some of the discussions that's been happening within the UK. So I'm one of 17 advisors to the UK government on what does the UK mean with regards to raw materials. How on earth are we going to be able to address this particular conundrum as a nation? And of course, one of the ongoing discussions is us saying, well, have you guys, to government, have you guys made your mind up as to what our industrial strategy is yet? Of course, we then have a conversation around, well, how many prime ministers do you need to have in a year, which I think we can all commiserate with together. But that's something there where we say, okay, well, a little bit of this is around, well, what are we aiming at? And then we can tell you if we can provide it. But then again, you've got this virtuous circle where we can constantly have this particular discussion. So it's a very long-winded way of saying, we need lots of new materials. In terms of what we actually need, it is usually it's determined by where the demand is coming from. And at the moment, there's quite a lot of uncertainty in terms of what that demand really looks like. From a mining perspective, of course, this is something that we can produce, but a lot of these materials are things that we haven't necessarily dug out of the ground before, certainly not in volume, and haven't necessarily got really, really good at processing them. So it's the processing bits that's the key, not necessarily the geologists to know where to find all of this. It's the metallurgists, it's the chemical engineers where things can get really, really tricky. How do you actually separate out those rare earth elements from one another? There's a reason why they all sit together in the same box in the periodic table, because they've all got the same characteristics. So these are things here where do these little challenges come through? The opportunity, however, of course, is for new markets to begin to spring up, which is really exciting. Also, as well, with regards to all of this, the demand is changing. And of course, with that, it's not just about which technologies are we designing, but it's also as well, how are they designed? So are we designing new technology so that if one bit wears out, you can easily pull, like, for example, I'm talking to you on an Apple Mac laptop, where if I want to change the battery, it needs to be sent away because there's no way that I'm going to be able to pull apart this Apple Mac myself and pull the battery out and put a new one in. So what that's doing is it's making it really, really difficult for me as the user to keep my Apple Mac up to date, unlike, say, a different type of laptop. But this is more prolific. If you look at a washing machine or whatever, how do we actually design them? Do we design them to be repurposed? Do we design them to be mended? Do we design it to be stripped down so that we can actually recycle the independent components by themselves? Rolls-Royce, for example, making jet engines, they actually design that. So there are 6 different layers of alloy that go on each of those blades within a jet engine. And the way that they have actually constructed it is to intentionally, so that they can strip each one of them back and pull them back to their original components so that those original metals can be reused. What they haven't done is create really, really complicated alloys that are almost impossible to then be able to pull apart again. So a lot of this comes into the circular economy. So the circular economy as a whole is not just how do we provide the raw materials in and how do we recycle it? It's also how do we actually design our technology? How do we use our technology? What are individual user habits, etc., that fit in there as well? So what are some of those uncertainties? Uncertainties basically being risks with regards to, or could be risks to certain people, with regards to exploring those new materials or producing those new materials. Well, we don't necessarily always know what the environmental impact of those new commodities might be it in terms of pulling them out of the ground or their end use, because they haven't been in circulation. So we don't have all the data to say this is what it might look like. What about the processing techniques? And of course, this is one of the big things with regards to rare earth elements. There's a reason why China's really good at it. They've been doing it for years and years and years and years and years. And perhaps historically, they haven't necessarily been constrained by the same environmental expectations as other nations might be. Notice how I put that very politely. Also, as well, we've got this technological demand for new commodities, just like I was mentioning earlier. But are we actually able to dig this stuff out of the ground? We need to be able to develop often new techniques to be able to extract these commodities. And then finally, a bit nitty gritty in this, what about the reporting code? So our ability to transparently and with a lot of trust say, this is what I think is actually in the ground, if it's something that we haven't looked at very much before. About 14 years ago, I helped an organisation to do some due diligence on a lithium asset in Western Australia, and immediately said, hang on a second, we've got a problem here, because the code or the guidelines that the geologists have been applying to it were basically what would be used for iron ore. And I said, hang on a second, your drill hole spacing isn't good enough for a lithium asset. And they said, but it's good enough for iron ore, it's good enough for lithium. At which point in time, we had a little discussion about geological models and how lithium might be formed in the Earth's crust compared to, say, iron ore. So these are things here where, again, there's a lot of shift. And so therefore, there's a lot of uncertainty and a lot of areas where we may make mistakes, but we need to be able to work together on all of it. Number 2, I'll speed up, I promise. Opportunities to make use of byproducts. Most of our critical materials actually are not the things that you would primarily go and dig out the ground. Most of them are byproducts of something else. So for example, if we take a little look at copper, of course, this is something here where you've got things, lovely things like cobalt, for example, which might be a byproduct effectively of digging the copper out of the ground. Now, this is great because what this means is that, okay, we've gone to the bother of digging a hole in the ground anyway. Let's take 2 things out of it rather than just one. Great. But that's easier said than done, because the style of processing, again, may require you, if you want to get the cobalt out, you might lose some of the copper, for example. So, okay, hang on a second, what's more important here? Also, again, what does this mean in terms of our ability to go back to old mine working? So the reworkings of tailings, either to get more copper out of it because our technology has improved, but also be able to take some of these materials that back 10, 15, 20 years ago, nobody wanted them. So there was no demand for them. So we can go back and do that again, which is great. But also as well, we've got a whole load of exploration projects where those explorers thought, hang on, I didn't find anything here. Well, maybe they did. They were just looking for the wrong commodity. So there's an opportunity to revitalize a whole load of exploration projects that were dogs or thrown on the, nah, you didn't find anything there. Hang on a second, maybe you did. So what about that data, all that data from those exploration projects that you can bring back to say, okay, now we're looking for different commodities. Can we put this back on the table again? So that's really exciting. So with regards to those making use of byproducts, again, some of those uncertainties that we need to be thinking of. So reporting codes, okay, really well structured for the stuff that we're used to. If we're digging more than one thing out the ground, what does that mean in terms of our reporting codes? And for example, JORC has been undergoing an update for the last couple of years, really to get ESG into it. Does it also still hold true for if you've got multiple commodities coming out the ground, which it does, which is great. What about tax status? So depending on where you are in the world, if you've put a load of waste into a pile, it's great, it has no value, it's written off. If that waste pile is now a stockpile, that means something very different from a tax perspective. So again, in terms of those kind of financial dealings, what does this mean in terms of critical materials? And then the final thing just to put on the table here is the carbon footprint of mining those byproducts. If you want to cheat, dig your gold out the ground and also say you're taking tellurium out of the ground as well, because then you can, depending on how you do your carbon calculations, you can split that carbon footprint in half, but it's cheating, so don't do it. But this is something here in terms of our understanding of how do we bring all of this together. There are still lots of big question marks there as well, so we need to be careful in terms of how we do that. Number 3, critical, remaining critical, question mark. Basically, everything is critical. So again, when I'm talking to governments around the world and say, oh, we're focusing on our critical materials, I'm like, please just get rid of the word critical. It's just materials, we need all of it. But this is all about a prioritization. And of course, that prioritization changes depending on where you are. And typically, countries or organizations will determine criticality as being the economic vulnerability against global supply. Okay, so that's what we're talking about here. So depending on what your demand is or your economic vulnerability is, that will change what's going on. And of course, when missiles started flying in Ukraine, for example, again, we saw a massive shift in these criticality assessments because things like nickel, for example, bounced around because a lot of it comes from Russia. So what you're seeing here is this really big focus in on what is critical. And the reason why it's important either to get it right, but also not to do paralysis by analysis, because at the end of the day, we need all of it. Notice how lithium only just makes the cut for the UK critical list. Now, this is hilarious because there are a lot of domestic companies who are making their name on lithium down in Cornwall. And we do have lithium in Cornwall, but we don't have anything near the amount of lithium that you guys have in Australia. But this is something here of, wouldn't it be bad if lithium didn't make the criticality list for the UK? So politically, this is something here where it's quite charged. And I spent a lot of time saying, look, put the criticality lists to one side. It's just a prioritization tool and get on with the big thing, which is actually how do we secure supply in general, and what is critical today might not be critical tomorrow. So these lists constantly change. Number 4, governments in the energy transition. Now, I mentioned quite a lot about this earlier on. Governments now have big skin in the game because they have committed to big targets. And most governments haven't got the foggiest how they're going to achieve them. And so therefore, there's a lot of head scratching saying, okay, how are we actually going to achieve these targets? Compared to 2021, the world has now come to the table in terms of mining. I was in the UK Foreign Office effectively a week or so ago, and they said that every single big trade agreement or multilateral agreement that they're walking into at the moment, somebody puts critical materials on the table. That's never happened before. Somebody putting materials on the table at every single one of those discussions. That is huge. Of course, then we get lots of phone calls saying, what's a critical material again? But that's fine because we can work through all of that. So this is massive. Mining has now got this big leg up, which is really cool. Of course, with all of this, we've got the need for speed. We need to get on with it. We don't have time to wait around for it. So in terms of those uncertainties, yeah, we can improve policy and regulation. So it focuses in on efficient but fully responsible mining, okay? So this is really important. We need this stuff fast, but we cannot create a massive disaster by digging it out of the ground too quickly without recognizing what all those threats might be and not taking advantages of the opportunities. Number 5, resource nationalism. Now, this is something which is really exciting and quite very interesting, to be honest, from a company perspective. Within the last week or so, Chile has basically done a massive nationalism push. Okay, so public-private partnerships is now the flavour of the day in a number of different countries, and this is fascinating. This is terrifying if you are a private company. Absolutely terrifying. Resource nationalism has been on the list of risks for many, many years, but not like this. This has come back in a big way. So what this means is that there'll be an awful lot of private investors, for example, or investors as a whole, thinking, hang on a second, what does this mean for us? On the plus side, actually, there's an increased scrutiny on government by population. So the Chilean population now saying, okay, government, you show us that you are responsible with regards to what you're doing. From the country itself, enhanced mineral security, because actually they're taking more control of the minerals coming out from their country. So again, see this from different perspectives. Nationalism is a threat with regards to a private company, but probably an opportunity with regards to a government. But actually, what do we actually need from a macro perspective? And then, especially because I'm sitting here in Brussels, and recently there was a European delegation that went to Chile and said, hey, we'll help you mine all your lithium, but you need to sell it to us because you guys don't know how to make batteries. How rude. So this is something here whereby Chile saying, hang on, we're going to go down public-private partnership routes. Actually, this is also combating that neocolonialism, which we are seeing coming from the likes of the US and Europe, for example. And I'm going to put the UK to one side on all of that. Number 6, massive opportunity for a just energy transition. And what do we mean by that? A just basically means justice. And so therefore using the fact that we're going through big change, etc., to make sure that the rich nations don't just get richer and the poorer nations don't just get poorer. And this is something here where what we can do is we can use this big change to benefit those nations who perhaps don't have that wealth to be able to drive an awful lot of the innovation, for example, that we're getting on the downstream activities. And of course, we've got that opportunity for new trade agreements. This is really important, where if I just quickly go through these slides here, if we take a typical mining value chain, so from exploration through to post-mining, and we say, okay, yeah, it's an exploration where you can have lots of ideas, but they all get knocked on the head as we say, well, hang on a second, what makes economic sense, etc. In that post-mine, i.e. I'm not calling this closure intentionally, in this close post-mining space, what actually happens with that land? Loads and loads of different options that we've got here. And of course, the time horizons are just huge. These ones here are just too conservative. From a government perspective, a nice way to actually think about mining, especially for those governments that aren't used to mining, it's a case that mining is just one massive construction project. It's just a big construction project that is there to unlock wealth for a more developed future, which all sounds a little bit cliche and everything, but actually this is what we're aiming at here. And there are various different guidelines that have been put together by the UN that actually focus in on this. And what we're trying to do with this, if we're looking at the triple bottom line, so from a financial, social, natural perspective, is to say, okay, well, what happens on this? Let's not just focus on what happens when we're digging stuff out of the ground and so hopefully making some money. Actually, what we're really aiming at here is what happens next, or what are you trying to build for properly in the future? So some really interesting dynamics that we've got there. And it's the government's responsibility often to say, we're focused in on the developed bit, not just the mining bit. It's what comes next. That's what we're focused on. And that's where market indicators, metrics, etc., need to be focusing in on more. It's not just about the price of metal. So finally, the final opportunity is because we've got all this change, we've got more stakeholders actually sitting around the table than ever before, more stakeholders taking an interest. And of course, it's by having those diverse perspectives that hopefully, and by listening to them and acting on them, we should have enhanced resilience for what we're doing. So people shouldn't be surprised when something changes within mining, because we've actually got all of this coming together. So this allows us basically to create a more robust environment in which we can do business. Finally, in summary, exploration and mining just got even more exciting. Woohoo, it's fantastic. The world is looking at us as the mining sector to deliver what it needs. Okay, so we've got to step up, and we can't just sit here and say, we should do this, we should do that. We need to get on with it and do it now. We're going to be helped by the fact that more people are around the table. Yes, they will be criticizing us, but actually that criticism is good and can be seen as constructive. And whilst technology eradicates the needs for certain minerals and metals, etc., actually, we need to produce what we can really quickly. Otherwise, we're not going to be able to get through this energy transition. Final thing to mention is that if you liked some of this, there's a big conference happening between the 9th and 12th of May that's online, is free, and the sessions are scheduled nice and early in the morning, European time, so good for you guys in Australia, which is looking at material value chains, the criticality of trust. So how do we build trust across all of this? And with that, I shall finish. Thank you very much, Evan.
Wow, that was a great talk to finish on. Thank you so much, Sarah. You covered so much, particularly in that tail end racing through those slides. But yeah, thank you once again. And I might hand over to Nick now, and that is the final talk. At this point, we tend to open up the session so that all remaining panelists can interact with our participants as well. So we might just press a couple of buttons to open the floor. But while we're just doing that, I guess if any of the panelists have any questions or comments for Sarah, feel free to fire away now. We might open up to let all the participants be heard as well. So we might just quickly do that.
So I'll jump in quickly. So a couple of things you mentioned, the JORC code. I love the letters RPEEE, which stand for eventual economic extraction. And at the moment, I think that is being perhaps overstated in the critical metals world. But on the other side, I suppose I would argue that the current modelling of ore deposits is driven straight around NPV and a 15-year mine life on a discounted cash flow model, which actually drives poor behaviour, because the best way is to dig it up quickly because the NPV goes up, and digging it up quickly actually sends more to the tails because it tends that the recoveries are poor. And I don't quite stay awake at night, but I'd love to hear ways in which, and especially, the big accounting groups and you, Sarah, would actually comment to say, how are we going to get around this problem if we're going to have sustainable mines operating? I mean, we all see Olympic Dam out there at 800 years or something, and they double the production. It goes 400 years, and the accountants go, that doesn't matter outside 20 years with a discounted model. So any thoughts in that space?
Yes, so just to hop in on that one quickly, Nick. Yeah, please, let's stop using NPV. It doesn't work. It's not fit for purpose. Don't do it. Don't do it. And we've known this for a long time within mining, yet for whatever reason, we still do it. And yeah, so I won't get started on that because we'll be here for another 3 hours. Yeah, let's stop using NPV and instead using lesser known tools like, well, what's the potential total cost of operation or ownership, for example, for that asset, bringing in things like the triple bottom line. So actually saying, okay, we can bring in some of the financial factors, but actually rolling in the natural and the social capital aspects as well, seeing things beyond the life of mine. Mining doesn't stop with closure. And yeah, it doesn't stop with closure. So actually aiming at that long-term benefit. The problem that we have there is, of course, those other factors are much more difficult to quantify. So they tend to be very qualitative and subjective. But I'll leave it at, yeah, please, let's stop using NPV. No one else is saving me.
I've heard similar things from, I'm not in mine planning or anything, as you see what I'm in, from colleagues here that talk about the same kind of thing. Yeah, it just doesn't work very well. When you said that, Sarah, it reminded me of TRIFR and lost time injury frequency rates and that kind of thing in safety, and how they are used very extensively, but they don't really reflect much.
James, Jason, other people online, comments and thoughts to wrap up, given our Q&A session is quite quiet.
Thanks.
You're on mute, Jason.
Thanks, Sarah. We're Carrie and I are in the same room, so we just need to make sure we manage the tech, so to speak. Look, I'm going to offer a personal opinion, and I think it's a complex topic that you're offering, Nick, because if you simply took a view from, let's say, a standardized, uniform, egalitarian society where we were all vested and interested in the best and optimal outcomes, agreed with your comment. I think where we introduced economic competition between, regionalization, we talked about localization, we talked about neo-colonialism. These are certain realities that, introduce a certain complexity to what we're looking at. And all we can do is move the dial as pragmatically and consistently as possible. And I think Australia does that very, very well, We certainly, from a social responsibility point of view, lead the world in actually setting some of these trends. Environmental, we're going to have to look at the technologies that actually we're going to introduce to think about, how do we think about, let's say, the tailings and the mineral resources that are left over there. And economics will drive that conversation. NPV certainly is a unidimensional measure, but it's something that you can't escape from. And we do need to broaden the lens, but right time, right place. I really like that chart that you had, Sarah, where if you took the 200-year view, what does that look like? All right. And so, I guess the point I'm trying to make is it is complicated and it will take time. And as different generations tackle these problems, different views will form. The best thing we can do is how effectively can we hand over a responsible economic environment to our children, right? And I'm going to use a very good cliche, Lachlan mentioned, the DRC, right? Going through their industrialization, we've been through that. I hope that sort of is a non-answer, but an answer. Back to you, Nick. What did you think?
Yeah, I mean, it was interesting to see other people come up online. Mark Berry came up online with another comment, but we just need to be more careful. And I think I said to a couple of people at the outset that we have this issue with juniors, that juniors are driven by a different price mentality about other people essentially buying their shares for essentially short-term gain, in the hope that they'll be bought out when they actually find something. And so that alone is a very short-term behavior that there probably isn't an answer for, given the great success rate that juniors actually have compared with the majors in finding ore deposits. So it's a very big issue that we all really need to deal with, and just be careful how we use it. And I did notice, for example, our federal minister used the word reserves of critical. We have something like vast reserves of critical minerals. And I was thinking, oh, she's got no idea what she's talking about. I mean, those sorts of comments don't help us, because we know all of what reserves means. It's easy to get out. We know what we're doing. But at this stage, we would say in most of the critical metal space that it's leading edge technologies, and there's a fair amount of uncertainty. And I'm not sure that's so well understood, and it's really up to us to make that clear to everybody. I think Europe, having been in the EU funding process or for the last 10 years, has been quite ahead of that in that game in many ways. But then you do get the problem that the people who actually come from Brussels or somewhere don't really understand, because they ask us why we wouldn't be doing something in central Germany where there's no Proterozoic rocks or something like that. And you're trying to explain why you're in different parts of Europe. So it's not an easy situation to educate the public in what is a complex a really complex issue that we all deal with.
Can I ask Sarah another question? Oh, sorry.
Yeah, on you go, Ben.
No,
Go
yeah,
on.
you go. You answer. Sorry.
And I had my headphones on. So yes, you can slag off the Europeans as much as you want because they can't hear you at the moment. It's all good, but absolutely. And I think that this is something where, so the Critical Minerals Act was leaked, and interestingly changed slightly between the leak and then what was formally published, because there were one or two absolute howlers in there that people pushed back on really strongly. There are still some big mistakes in the Critical Minerals Act at the moment in Europe, and that's where people are trying to iron them out. Mining within Europe is not well respected in the slightest, and actually one of the reasons why the document I'm here on today has taken so long is because people don't think that mining is needed at all. So that's the starting base. So you've got some fantastic technological development. You've got nations that have been built on mining, but we've conveniently forgotten about it. But from a social perspective, people just do not want mining at all within Europe, which then, of course, leads to the whole neocolonial problem, shall we say, with regards to that. So it's really interesting. And I think that that's something where the context of mining looks very, very different in different parts of the world, and that needs to be acknowledged. And it's difficult for politicians, civil servants to then say, okay, well, what do we actually write down here? Because they get absolutely hammered. For example, within mining, you cannot use the word social license to operate. No. Social acceptance, no. Things like that, just they're banned. Also as well, in terms of as low as reasonably practicable, not allowed. You're not allowed to write something that says that somebody might be hurt whilst at work. Yep. And I've got a conversation with one of them today where I'll say, congratulations on making it to the meeting. Yep. So it's really difficult from a risk perspective. And of course, again, there's an awful lot that gets lost in translation. Yeah. I'm going to have a great day.
Well, and I mean, you're talking about this sort of stuff, and we're talking about speeding it up. And yet you look at the way in which, so I've been involved in Northern Finnish projects, the way in which the approval timelines are out there. And we're at the stage now for one project where oxygen isotopes are being measured in water at minus 800 meters as part of the environmental approval process. That is going to make, if it happens like that, which seems crazy to me, but maybe I'm still too old and white and grey haired, but it does seem like we've turned the dial just a bit far when we're doing that sort of thing to get a metal operation actually approved.
Can I ask Sarah another question? Is that all right?
Yeah, go, Ben.
You had a cool slide showing the upside and downside parts of risk and the delta between them being the value that's created. And a lot of that was around the key idea that, when you're thinking about risk, what you're really looking for is sources of uncertainty and trying to manage that and knowing when to act and all that sort of stuff. Another part of your talk was showing a network diagram of how different kinds of risk interacts or interrelates or interconnects. And I just was wondering, when you're trying to connect different kinds of risk information together in order to manage it together, does that create new uncertainties, that act of interconnecting things? And can you explain that a bit more and how you manage that?
Yeah, sure. So when you're creating that network or that map, and as Deborah, I think still on the call, knows and loves, we always do this in risk workshops. So it's all about making things, taking all of the magic out, well, putting the magic in, but taking the complexity out. And so saying to everybody, okay, well, what do you think the risks are, or post-it notes, and basically creating that network on a wall. And by that, you're being really inclusive as well, because somebody might put something up there and, oh, that's not a risk. That's actually a driver, but you're not having that debate around whether somebody doesn't really know what a risk is or what a hazard is or whatever. You're just getting it up there. Now, the thing is, once you've got that network, as soon as you then think, okay, well, let's change something in it, it does change the configuration. And what as well, especially if you're then going, so the example that I had up there is a very crude example of a tailings facility failing. And so that's something where if you say, right, well, what is actually what's the risk here? Is it the catastrophic failure of the tailings dam? Or is it that long-term environmental damage that's going on there? Or is it the inability to operate as a company? Or was it actually not investing in it in the first place? Or was it not doing the raise to specification? You know, so, and again, notice that I've gone for all the negative things there. Depending on who you are, that risk will be different. And that's one of the big problems that I think we often have when we're using things like a risk bow tie. Now, bow ties are awesome as risk tools, but that debate around what are you putting in the middle is one of the most difficult things with regards to that bow tie. So you're totally right, Ben, in terms of as soon as you choose to decide to change something and you enact that change, then it does actually nudge things around. So what you're trying to do is say, right, I'm looking at this system. If I make change A, B, and C, what does that then do to this configuration? And how far upstream do I go? Because if you go further upstream in terms of that network, the bang for your buck can be absolutely huge in terms of what then trickles out. And, you know, and again, coming back to safety, if you change the design of that facility so that nobody has to work at height or whatever, it's no longer a risk because no one's going to be standing on top of a ladder or whatever. But that's something there where, to be completely honest, the safety specialist, usually, it has to be someone who actually designs the facility in the first place. It's probably somebody within accounting who can release the budget. So all of those things there, actually seeing things as a network and then saying, okay, it might cost us a bit more money to design this facility so that nobody has to work at height. But actually, to be honest, that's got us thinking, and we can design this so we're actually more efficient in the long run. So we've eradicated that threat, but also we've built in that opportunity that otherwise we'd never have looked at. So that's what's looking at here. And that's why as well, in terms of the diagram of the mining value chain and saying there's all of this opportunity up front in the exploration and the design phase, is saying if we are actually thinking about this for 200 years plus after mining, now we're talking. It's not just about optimizing getting the copper and the cobalt and whatever out of the ground. It is optimizing the development that comes next. And that's really interesting. Does that answer your question, Ben?
Yes. And I feel like I've opened up many more, but thank you.
Okay, well, I will actually leave it to Evan on behalf of the UQ side of the seminar series. We are now up to our allotted time, and pass over to Evan.
Yeah, great. Thanks, Nick. Just to echo the comments from before, thank you very much to all our presenters this afternoon. Carrie, Jason, James, Ben, Lachlan, who had to duck off just earlier, and Sarah, you've really made for a very thought-provoking and informative afternoon. And sincerely, we appreciate you being part of this collaborative webinar series with the GSQ and University of Queensland. So we've been running these for a couple of years now, and we're really thrilled that they're continuing to push the boundaries and share such useful information across our industry. So thank you once again. We've got our next webinar. I think Nick put a note in the chat. I put one as well on the 25th of May, all about the Tulibuck formation. So there'll be some interesting, really technical talks to come out of that one. And thank you for sharing the information about your conference as well, Sarah. I'll be looking that up and joining some of those conversations. But yeah, thank you once again. We really do appreciate it. Thank you, Nick and Katerina for hosting. And yeah, looking forward to speaking with you again soon. Thanks so much.
Take care, everybody.
Thank you. Bye.